Okay, so convergent boundary, this is the first case. This case was discussed in last lecture. So let's see, second case, that is divergent boundary. Now, places where plates are coming apart are called as the divergent boundary. Divergent boundaries means what? Two successive plates moves apart, or you can say that they just repulse from each other. And due to this repulsion of these two plates, what happens? One valley type area, or you can say that rift is generated. And due to generation of the rift, what happens? The molten magma wells up on the surface. So this boundary happen here two lithosphere plates move apart. Generally, these divergent boundaries are formed where two successive plates move apart from each other. So as the plate separates along the boundary, the block between the faults is nothing but the particular cracked area in between two plates. So cracks and drops down this particular area, fault area cracks down, or you can say that drop down into the soft plastic interior. Now, what is exactly what is called as the soft plastic interior? It is nothing but the asthenosphere. We had discussed earlier the properties of asthenosphere and lithosphere. So, asthenosphere is somehow just a liquid type material. It includes liquid type material. So this particular fault area cracks and drop down into the asthenosphere area. Then the sinking of this block forms a central valley. Now, due to sinking, or you can say that due to repulsion in between two plates, what happens? The central valley is formed, and this valley is generally called as the rift. So, rift is formed. So these types of boundaries generally occur along the spreading centers where plates are moving away from each other. And in this particular area, in this valley or a rift, new crust is created by upward movement of the molten magma. Because as and when uh, these particular plates move apart, then what happens? This area or in this particular fault zone, valley is created, and due to creation of the valley or rift, what happens? The underlying liquid material, that is molten magma, comes up, or you can say that wells up on the surface. So divergent boundaries are also called as the constructive zones. Now, why divergent boundaries are called as the constructive zones? Because in divergent boundary, in this particular case, new particular rock mass is constructed or created. Okay, due to welling up of magma, new rock mass is produced or is generated, created in between two successive plates, and that's why these divergent boundaries are also called as the constructive zones. Before that, we had discussed first case, that is convergent boundaries. But in that particular case, what we see, we just see the collision between two plates. Due to collision, what happens? The destruction of the plate is takes place, and due to destruction of these two plates, it is also called as the destructive margins. So convergent boundaries are also called as the destructive margins as well, and divergent boundaries are generally called as the constructive zones or constructive margins, because in this case new rock masses are formed or created, and that's why it is called as the constructive zones or constructive margins. So generally, uh, let's see, magma shifts upward to fill the cracks. Cracks in the generally you can say that cracks are formed in between two plates, or it's also called as the fault, or it is also called as the rift. So in the rift area, this magma will comes up and it will fill the particular portion, particular area. Then here you can see these are the two images. You can see these are the two successive plates. Let's see first image. These are the two successive plates. So after repulsion of these two plates, here you can see in between two plates, one valley region is formed, created. And due to formation of the valley region, what happens here you can see underlying portion, underlying magma, or you can say that the liquid material is wells up or comes up to the surface. So this is one type of cross section. You can say that in cross section you will able to see these two particular plates, successive plates. You can see another figure. So in this figure you can see the top view or plan. So in this case also you can see two different plates are there. They are moving away from each other, and one particular fault zone is created. So in between these fault zones, that particular liquid material, that is magma, it comes up to the surface and it forms the solid mass, rock mass, because after coming up to the surface, due to the particular solidification, you can say that due to solidification of the magma, rock masses are generally formed or created in that particular valley area or rift area. So earthquakes occurs along the fault zones, and volcanoes forms where the magma reaches the surface. Now generally occurrence of earthquakes, it generally takes place along the fault zones. I think in last lecture we had discussed about different types of the fault zones in between plates. There are total 9 to 10 different plates, tectonic plates are there. Indo-Australian plate is there, then South American, North American plate, and African plate is there. So in the contact area or in between two plates, there is one fault is present. So along these different particular faults, earthquakes are occurs. About 95% of the earthquake occurs along these faulting zones. Here you can see in image number 2, this is the fault zone. In between two plates, here you can see this is the valley region, ridge, or you can say that a rift area is there. And along this particular valley region, uh, most of the earthquakes are occur. Okay, it is also called as the fault zones. So in this way, magma wells up on the Earth's on the particular surface, and it will form the new rock masses, or it will construct new rock masses, and that's why this particular divergent boundaries case is called as the constructive margin. Now, divergent boundaries in continental regions are known as the rift zones. Generally, as far as the continental regions are concerned, whenever this particular divergent boundaries are takes place in the continental regions, these are called as the rift zones. So in this type of the boundaries, generally the molten rock from the underlying mantle is nothing but the asthenosphere. Okay, so rises to the surface. Here it cools down, or you can say that the solidification of this molten magma, and after cooling, after solidification, it becomes a part of spreading plates. Okay, it will becomes a part of small spreading plates. So this is nothing but the divergent boundaries. Due to the repulsion of two successive plates, one valley region is formed, and from this valley region, from this particular cracked portion, molten magma from the asthenosphere or underlying layer wells up into the onto the Earth's surface, and after some time it will cools down or solidifies, and after solidification, the rock masses are formed from this molten magma, and that's what is called as the constructive margin. Now, generally, the earthquake occurs at a shallow depth and are mostly small. Generally, The occurrence of earthquake with different magnitudes, generally greater than 6, is rare as far as the different occurrence of the earthquakes are concerned. The magnitude of most of the earthquakes are less than 6, or you can say that in between 3 to 5. Okay, so generally, in this particular case, as and when the divergent boundary case is takes place in any particular area, due to which some earthquake maybe occurs because these two plates are moved apart from each other, and due to these movements, some earthquakes, some earth movements may be created. But this, the movement, you can say that the magnitude of this particular Earth surface due to these divergent boundaries is generally in between 3 to 5 or 3 to 6. Now, next one is the transform boundaries. The places where plates slides horizontally past each other are generally called as the transform boundaries. Now, this is the third case. In this case, neither any particular constructive margin created nor any destruction is takes place. And that's why this is the third case. It is called as the transform boundaries. Now why this particular case is called as the transform boundaries? Because in this case, two successive plates slides down in horizontal plane, places where plates slides horizontally past each other. And due to sliding of these particular plates, the boundaries of these two plates, faulting zones of these two plates may transform. And that's why it is called as the transform boundaries. So most transform faults are found on the ocean floors and few occurs on the land. For example, San Andreas fault zone, which was in California. So this is one example of a transform fault. Now, as far as these transform boundaries are concerned, these boundaries are marked by features like stream beds that have been split in halves, and the two halves have been moved in opposite direction. So let's see the image, then you can able to understand how the plates are moved. So here you can see one image is there. So in this image you can see these two successive plates are slides down, okay, in a horizontal plane, okay, and due to this sliding, the boundaries of this particular plates may just transform, may just move, and due to which it is called as the transform boundaries. So as far as the first two cases are concerned, in first two cases, what we see in first case, collision is takes place. In second case, what happens? Two plates moves apart, and due to moving apart, some new particular constructive zone is formed. And here, this is the third case, transform boundaries. In this particular case, what happens? The movement of the plate is takes place, but it is in horizontal plane, in horizontal direction, or you can say that in lateral or longitudinal direction of the plates. So friction between these plates can be so great that very large strains can build up before they are relieved by large earthquakes. So generally, whenever such types of conditions happen, large strain energy can be built up in between two plates, and due to this building of large strain energy at one point, this particular two plates may split up, and due to splitting of these particular plates, ultimately what happens? The movement of the earth surface takes place. So due to this particular movements, earthquake occurs. So this is all about the transform boundaries. Then let's move to the next point, that is seismic waves. Now, during an earthquake, large strain energy is released that we had discussed earlier in many lectures. Now, this strain energy is released in the form of elastic waves. Okay, those are generated at the focus. So these waves are generally called as the seismic waves. Okay, so due to induction of the strain energy in between two plates, after releasing of this strain energy, some elastic waves are created, and these elastic waves are generally called as the seismic waves. Okay, so seismic waves are waves of energy that travels through the earth's layer. So some of the waves are travels only on the earth surfaces. Some of the waves are travels in the body of the earth surface as well. So seismic waves are results of earthquakes, volcanic eruptions, magma movements, large landslides, and large man-made explosions. Now, why the seismic waves are created? These are some reasons. First reason is earthquake, occurrence of the earthquakes. It will definitely just form some seismic waves, then volcanic eruptions, then magma movements in upward direction. Uh, the next one is the large landslides, and last one is the large man-made explosions. So some artificial, or you can say that anthropogenic, particular um, explosions may be happen, and due to this anthropogenic explosions, what happens, earth movements takes place, and due to movement of the earth, some seismic waves are generally created in that particular area. So the propagation velocity of the wave depends on the elasticity and density of the medium. Now, what is the medium in this case? Can you tell me what is the medium in this case? Medium काय असेल सांगा? What will be the medium in this case? Seismic waves कुठे जनरेट होत आहेत? अर्थ सरफेस वरती किंवा बिलो द अर्थ सरफेस here the focus is generally uh, positioned. बरोबर आहे. So medium is nothing but the earth surface. Now, as we see the medium, as we see the earth surface, different layers of the earth, each and every layer of the earth having different properties, either it may be physical or a chemical properties as well. So due to different material, also it will possess different elastic properties. It will also possess different densities. Take example of lithosphere and astronosphere. We had discussed earlier. Lithosphere is somehow brittle material like a concrete, and astronosphere is somehow flexible because it is somehow a liquid material. It contains somehow liquid materials, and that's why the density of two spheres, lithospheres and astronospheres, are different. Elasticity or elastic properties of two particular mediums are different, and that's why propagation of the velocity or propagation of these seismic waves, movements of the seismic waves, are different in different mediums. Those are particularly observed different speed in lithosphere, and those are travel from astronosphere with a different speed because both of the mediums possesses some different elastic properties and chemical properties as well. So generally, as far as the propagation of velocity is concerned, or movement of the velocity, or you can say that the seismic waves are concerned, it will totally depends on the physical and chemical or mechanical properties of this material. Okay, so composition of lithosphere and astronosphere is one type of important parameter on account of velocity of particular seismic waves are concerned. Then the velocity tends to increase with increase in density. As and when density increases, definitely the velocity of particular medium increases. So as we move deeper in the Earth's surface, velocity is going to increase because the density of the crust. Earlier we had discussed there are three different particular sections of the Earth. Okay, mantle is there, crust is there. Okay, so as we see the different particular layers of the Earth, each and every layer possesses different properties. So, uh, as we consider the particular core material or core portion of the earth, so this particular core portion has a very high density as compared to crust and mantle. Okay, so in core portion, the velocity or propagation of the particular velocity, or you can say that the speed is more as compared to mantle layer and particular crust layer. So this is the difference because both the particular layers, or you can say that three layers, they possess different properties, physical as well as mechanical properties. So earthquake creates distinct type of waves with different velocities. As far as the earthquake is concerned, it will possess different types of the waves. There are different waves are there. So here you can see one image is there. It will just indicates the body waves and surface waves. So these are the, as far as the seismic waves are concerned, there are two important or two main types of the waves. First one is the body waves and second one is the surface waves. So here you can see how the body waves are propagated and how the surface waves are propagated. Here you can see surface waves are only propagated on the some topmost portion of the earth surface, and as you see the body waves, here you can see at the bottom where the epicenter is located. So from this epicenter, particular body waves are propagated in different direction. Okay, so here also you can see different geological layers, different geological stratas. Here you can see, you can observe. So this is the soil material. So after that, underlying layer is of different types of the rocks or geological strata. So each and every layer has a different properties, physical and mechanical properties. So here you can see the original static position of the earthquake. So during the earthquake, what will be the behavior of the structure? Structureचं behavior काय असेल? एखादं पर्टिक्युलर बिल्डिंग आहे. What will be the behavior of that particular building during the occurrence of the earthquake? So here you can see the deflected shape of the building due to dynamic effects. So some drift may be observed here. You can see. So deflected shape of the building due to dynamic effects caused by the rapid ground displacement. So due to rapid ground displacement, some drift may be observed in the buildings. So for resisting this particular drift, we must have to use some ductile material during the construction of the buildings. Okay, we cannot use only concrete material for construction purpose. You must have to use steel along with concrete. Okay, so that we can uh, resist, or that particular structure can resist all different types of the ground movements or ground shakings. So here you can see surface waves are there, and another one type is the body waves are there. Okay, and here you can see the epicenter is located here, and these body waves are propagated. Likewise, the surface waves are propagated on the topmost portion of the earth surface. So the next point is types of seismic waves. So seismic waves are classified into two groups. In that, first one is the body waves and second type is surface waves. So these are the two types of the waves, body waves and surface waves. So let's see the body waves first. So generally body waves are of two types. Again, body waves are subdivided into two types. First one is the P waves and second one is the S waves, or also it is called as the primary waves and secondary waves. So body waves travel through the interior of the earth along the path controlled by the material properties like density and the modulus of that particular material. So, uh, as far as the body waves are concerned, these are travels through the interior of Earth. Here you can see in the image. Here you can see these are the body waves. Those are travels through the interior of the Earth. Okay, so propagation of the body waves is generally takes place below the Earth's surface, and that's why it is called as the body waves. Okay, so body waves are further subdivided into two types. In that first one is the compressional waves. It is also called as the primary waves or P waves. And second one is the shear waves. It is called as the also called as the secondary waves or S waves. So body waves are generally divided into two parts. First P waves and second one is the S waves, or also it is called as the compressional and shear waves. So let's see first compressional waves. Now, as far as the P waves or compressional waves are concerned, they are known as primary waves, push or pull waves, longitudinal waves, or in some cases it is also called as the compressional waves. Now, why these particular waves are called as the longitudinal waves or compressional waves? Why? Because behavior of this particular waves, here you can see at the bottom one figure is there. Okay, in this figure here you can see some dilation and refraction is takes place. Okay, so as and when earthquake occurs, particularly during the occurrence of the earthquakes, earth moves in a lateral, or you can say that in horizontal direction. So generally during the movement of the earth, as far as the P waves are concerned, the movement of this particular earth's surface is in the longitudinal direction, or you can say that in the particular in the horizontal plane. It will not generally you can say that it will not move in the vertical plane or vertical direction. It will only move in the horizontal direction. So, due to movement of this particular P waves in longitudinal or horizontal direction, some push and pull waves are generally particularly generated in this case. So, in some cases, compression created, or in some cases, dilation is created. So, dilation is nothing but the expansion or inflation of the particular Earth surface, and compression is nothing but the particularly compressed or compression of the material. Okay, so P waves causes particle of rock to vibrate in longitudinal direction. So as far as the P waves are concerned, these are only generated along the longitudinal direction, or you can say that in the horizontal plane, that is in the direction of the propagation of the waves. So it involves successive compression and refraction, or you can say that successive compression and dilation. So successive compression and dilation is takes place in this type of the waves, and that's why it is called as the compressional waves or longitudinal waves, because these particular waves are moved in longitudinal direction, and frequently compression and dilation is takes place during the movement of the earth surface, and that's why it is called as the compressional or longitudinal or P waves. Okay. So, as far as this particular waves are concerned, these waves can travel through any type of material, including fluid material or any type of solid material is there, or you can say some other mediums are there. And these particular waves travels faster than the S waves. Generally, uh, The speed of these particular waves are 1.7 times S waves. Okay, so movement of these waves are more than movement of S waves as well. Now, in air, these waves takes the form of sound waves, hence they travel at the speed of sound. So as far as the air medium is concerned, also the speed of these particular waves are more as compared to S waves and some other particular waves are there. So now, as per the properties of this particular compressional waves are concerned, the nature of this waves is longitudinal because they move in the longitudinal direction. Then P waves are fastest waves and their velocity is somehow, or you can say that about 1.7 times the S waves. Then they can pass through any material like a solid, liquid, etc. etc. And P waves obeys the all laws of physics and they are similar to sound waves also because they travels in the air mediums as well. Then they cause momentarily the volume change in the material through which they pass without any momentary shape changes. Now, as far as the particular P waves are concerned, due to the frequently or due to the successive compression and dilation is concerned, due to this compression and dilation, some volume changes may be takes place during the earthquake. Okay, so as far as these P waves are concerned, in this case, volume changes may be takes place in the particular material. Then generally damaged caused by this particular P waves since they are longitudinal in nature. They cause structure to move in the vertical direction. This do not affect its safety as they are designed for the vertical loads and hence they are not significant or do not have significant importance as well because as far as these compressional waves are concerned, these are one type of a body waves. Those are generally takes place under the Earth surface, sorry, under the body of the Earth, and that's why, as far as the different types of the buildings or structures are concerned, uh, these are not that much significant. Okay? So these are all about the properties of P waves, or you can say that compressional waves. Then next type of the wave is shear waves, or it is also called as the secondary waves or S waves. Now, S waves are also known as secondary, or in some cases it is also called as the transverse waves or distortional waves. Now, uh, here you can see at the bottom one figure is there. So in that particular figure, you can see the movement of the Earth's surface in its particular shear waves. Also in vertical direction or in vertical plane, movements are in vertical plane. Okay, so up and down, some troughs and some crests are formed due to movement of this particular Earth surface. So the material properties of rock generally oscillates at a right angle to direction of propagation of these waves. So S waves are vertically and somehow horizontally polarized, uh, and that particular types of the waves are known as SV waves and SH waves. Okay, shear vertical waves and shear horizontal waves. So some particular waves are moves in the vertical direction, some of them are moves in the horizontal direction. So again, they are generally split up into two types. First one is the SV waves and second one is the SH waves, respectively. So S waves involves successive crest and troughs. Here you can see in the image also you can see the successive crust and troughs are formed during the movement of the earth. So secondary waves, generally called as the transverse or shear waves, these waves arrives at a seismograph stations after faster moving of the P waves, because we had discussed earlier that movement of the P waves are higher than the S waves, and that's why S waves arrived at a seismograph station after the faster moving of the P waves and displace the ground perpendicular to the direction of the propagation. So displacement of the particular Earth's surface is in the perpendicular direction. Okay, that is, you can say that in vertical direction. So propagation direction of the propagation of the waves is horizontal. Waves are particularly propagate in horizontal direction, and the movement in this particular case, movement of the Earth's surface somehow in perpendicular direction as well. So since fluid do not support the shear stresses, S waves cannot found in fluid. Now, as far as the particular S waves are concerned, let's discuss some properties. These are the transverse waves, transverse in nature because they just propagate in the perpendicular direction of the propagation. That's why it is called as the transverse waves. Then the velocity of this particular S waves, whatever, the sulfur. Oh, okay. झाले आता एक 15 मिनिट. Okay, so as far as the properties are concerned, the velocity of S wave is directly proportional to the shear strength of that particular material through which they pass. Because as we see the Earth surface, there are different particular layers are there. Each and every layer has different properties. So hence, these particular waves cannot pass through liquid material since they do not have any shear strength. Because as we as we consider the liquid material, any type of a liquid material, either it may be water or some other type of material, this liquid material do not have any shear strength, and that's why this particular S waves or shear waves cannot pass through this particular medium, liquid medium. And S waves are similar to sinusoidal waves. It is also called as the harmonic waves. So velocity of these S waves is less than the P waves, and generally these S waves distort the instantaneous shape of the material. Now, as we see the particular material, any earth surface is there, where the S wave takes place or occurred, what happens? The instantaneous movement or changing in the shape. You can observe here, you can see some successive troughs and crests are formed. Okay, so this instantaneous movements, instantaneous changes in the shapes maybe takes place due to the shear waves. Then, as far as the damage caused by these particular waves are concerned, yes, waves cause shaking of the structure in horizontal direction and thereby including large shear forces in the structure. So, as and when particular shear waves are occurred, what happens due to occurrence of these shear waves? Generally, different types of the particularly shear forces may be induced in the structures. Okay, so for resisting these particular shear forces, we must have to use some ductile detailing uh, at the particularly you can say that the section of the beam and column. Okay, so this is one type of a damaging effect of particular S waves because due to traveling of these S waves, it will induce some shear forces in the structures, and due to occurrence of the shear forces, differential settlement may be caused in the building. So for resisting this differential settlements, or we can say that the destruction of the horizontal structural elements like beams, so we just use or we may use ductile detailing for beams and columns so that we can resist this shear stresses or shear forces. Those are generally induced in the structure. Then surface waves are generally again subdivided into two types. First one is the release waves and second one is the love waves. So here you can see again surface waves. Particularly, these surface waves are subdivided into again two types. First one is the love waves and second one is the release waves. So generally, as far as this particular two waves are concerned, let's see first love waves. So love waves cause surface motion similar to that caused by the S waves, but with no vertical components. Now, I take one example of the L waves. Can you see some crawling animal like a snake? The snake just moves in the forward direction. So in that particular fashion, the movement of the earth takes place in the L waves. Okay, so in zigzag fashion. Okay, so occurrence of the particular L waves is in the fashion of zigzag way, or you can say that uh, snake is one example of this particular love waves. So movement of the snakes in the forward direction in that particular fashion, these love waves are travels in the particular earth surface. So L waves are always dispersive because they can only propagate in a velocity layered medium. So generally these waves are dispersive one, and these are only generated, only moves at topmost portion of the earth only. It will not just go deeper in the earth surface. And that's why it is called as a surface waves, one type of a surface waves. Here you can see one image is there. So in this image you can see topmost portion of the earth just moves in a zigzag fashion, and underlying portion of the earth surface, here you can see underlying portion is as it is. It will not deflect, it will not move in either in horizontal or vertical direction. So this is why, due to this, or due to which these particular waves are called as a surface waves, because some portion of the particular earth crust, earth surface only moves or only just deflect uh, in this fashion, and that's why it is called as a surface waves. The amplitude of these waves decreases with the depth. Generally, when these particular waves are occurred, particularly some movements are takes place at the surface of the earth only. So as an when these particular waves are takes place, the movement is generally takes place in two direction. The earth surface moves in horizontal plane as well as in vertical plane, somehow in vertical plane, but at particular depth. Okay, here you can see some arrows are generally indicated here. So this is indicates that the movement of this particular earth surface in horizontal direction, as well as at the same time this earth surface moves in vertical plane as well. Here you can see some troughs and crusts are formed during the movement of this earth surface. So it indicates that these love waves are moves, or you can say that love waves move the earth surface in both the planes, in a horizontal plane as well as in vertical plane, but at a specific depth. Then the next one is the release waves. Release waves makes a material particle oscillate in an elliptical path. in the vertical plane. So as far as these release waves are concerned, the movements of the Earth surface is only associated with the vertical plane. In horizontal plane, it will not associated with some movements or any type of the displacement as well. So the velocity of the release waves depends on the Poisson's ratio of the material through which they pass. Now, as far as the velocity is concerned, it will depend on the Poisson's ratio of the materials in the sense the strata of that particular crust, particular mantle, or particular, you can say that core portion. Generally, as per the release waves are concerned, they are only travels through the surface, and that's why we will just dealing with only the crust portion because they are not goes deeper in the earth section, and that's why we cannot take into consideration some layers of the mantles and cores because they only travels through the topmost portion of the earth, and topmost portion you can say that this is the one type of crust portion, upper crust, or you can say that lower crust. So here you can see this is the image. In this image you can see the movement of the particular Earth surface yes, takes place, but it is only in the one plane, that is in vertical plane. In horizontal plane, there is no any type of a movement that takes place. So this is generally called as the release waves. Okay, so these are the main four types of the waves, seismic waves. Okay, first one is the P waves, then second is the S waves, then love waves, and last one is the release waves. So, as we see the movements of the Earth in the different cases, there are the particular different properties as well, or you can say that as far as the movement is concerned, it will depend on some physical and mechanical properties of particular earth material, like modulus of that particular material, density of that particular material from which these different types of the waves are passed. Okay, so this is all about the types of the seismic waves. Okay. So with this, we will stop here. So in next lecture, we'll discuss next point, that is magnitude and intensity of the earthquake. What is exactly the basic difference between magnitude and intensity of the earthquake, and how it is generally recorded, how the magnitude of the earthquake is recorded, and how the intensity of the earthquake is recorded, which types, which types of the particular methods are used for the both the particular magnitude and intensity that we will discuss in the next lecture. So meanwhile, we'll stop here.